All right, so today what we're going to do is we're going to begin a new idea. Probably not new to you completely. You've probably seen some of these ideas before, but we're going to make sure and really get it down. So we are going to talk today about what's something called the Cartesian plane. All right? Now, it's called the Cartesian plane because it's named after a French mathematician named Descartes. So you don't have to really worry about that, but you do need to know the terminology. Because when you're asked to work with this, they're going to tell you to work using the Cartesian plane. If you don't know what that means, you're going to be in trouble, right? So remember, half the battle in mathematics is the vocabulary. If you understand what a phrase or a word means, then you know what to do when you see it, right? And too often, all we concern ourselves with is the problem. We don't focus on the ideas behind it and the vocabulary, right? So as we move forward, the vocabulary is really important. Say, for example, the answer when you add is called a what? Sum. The answer when you subtract is called a difference. The answer when you multiply is called a product. Make me proud here. The answer when you divide is called a quotient. Yes. You must know those. They should be as ingrained in your brain as your own name. Okay? Whatever that is this week. All right? Okay. Here we go. So what we're going to do is we're going to go through an Education Perfect. Now, it does a great job of explaining each piece, and it's got some great visuals, and that's why I'm using it. I think it's a little simplistic, and you need to make sure that in your notes, listen to what I'm telling you to write down. I'll underline it, and if there's anything else on there that I want to use to clarify, I'll write it down for you, right? But your notes need to be clear. Because remember, it's not just about looking at pictures and looking at examples. It's about knowing the process of knowing the pieces, knowing the vocabulary. Okay? So let's go to that Education Perfect and begin our look at the Cartesian plane. So, the Cartesian plane is a useful tool. It's named after René Descartes, who was the first one to publish one. And if you look, here you go. This is what it looks like. It's a grid, and it has two number lines. And we'll talk about each piece of it, so don't worry about it. Just soak in the picture. So, okay. So, and it's named after René Descartes, and you might have heard his most famous quote, "I think, therefore I am." You might have heard that somewhere. Maybe not. Who cares? Okay. Education Perfect is not Education Perfect without something silly. So there you go. All right. There we are. So that must be Wellington.
Windy.
Okay. The Cartesian plane is basically just two number lines that meet at right angles. Now that is critical. The Cartesian plane. So the Cartesian plane is two number lines at right angles to each other. Okay? So the Cartesian plane is two number lines at right angles to each other. And remember back when we looked at things, we said that right angles mean they meet at a perfect corner, right? Sometimes they put that little square, but we don't need to worry about that right now. Okay? So two number lines that meet at right angles of each other. Okay? Okay. And so if you look at these, now notice there's no grid on this one. They don't have to put the grid in. But notice that these are two number lines and they cross, and right here where they cross makes a perfect square corner, right? That's how you know it's a 90-degree angle. Yeah? Okay. And this gives us a two-dimensional plane rather than a one-dimensional line. If you just had a straight number line, all you could do is go right or left, right? But with this one, we can go right or left or up or down. Okay? So two dimensions. All right. The two number lines which form the Cartesian plane are named axes, and the singular name for that is axis. Okay? Now, you can write that down if you want to, but know that it's axes or axis, but we're going to write them down in a second when we talk about them. So, right? The horizontal number line is called the x-axis. Now, you will see times when it's named after a different letter. Say, for example, you're measuring time, you may call it the t-axis. But in general, the Cartesian plane is usually called, the horizontal one is called the x-axis. What does horizontal mean? It's the flat one, right? Okay? And if it's the flat one, it moves right and what? Left. Yeah? Okay. Then there's another axis that goes vertically, and that one is called the y-axis. What does vertical mean? Straight up and down, you betcha. Okay? So we have one that's vertical and one that's horizontal. Okay? Which one's vertical? Y. Which one's horizontal? X. Always. Never changes. Okay? So. No, they're both straight. Okay. All right. Okay. So just like in the picture here. Yeah. So look at the X is across and the Y is up and down. So right and left and up and down. Okay? Still don't think I'm quite following you, but probably so. Good. All right. Now, this is what is super important. So focus here. Okay? Every number has a unique position on a number line. Okay? Every number has a unique position on a number line. So in other words, if you have a positive 5, it fits in how many places on the number line? 1. Nowhere else can it fit. If you have a negative 2, it fits one place on a number line, and that's it. Do you agree? All right? Okay. And so that unique position is very important. On a Cartesian plane, there is a unique position for every pair of real numbers. So write that down, please, and then we'll talk about it. So on a Cartesian plane, there is a unique position for every pair of real numbers. So on the Cartesian plane, because we have two number lines, we need two numbers. Does that make sense? One number line, you only need one number, but two number lines requires two numbers. Okay? So they always come in pairs. A pair means two, right? Okay? Right. Okay? And it's always one on the x-axis. Whoops. So one, they didn't put one, so I'm going to put that number in, that word in front of this. One on the x-axis and one on the y-axis. Okay. Okay, so you have to have an x and a y in order to graph using the Cartesian plane. If we were just plotting something on a number line, all we need is one number, right? Yes? Because in this course we're only dealing real numbers just means it can't be imaginary numbers. It can't be irrational numbers like the square root of 5 or something. It has to be a number that you can actually count. That's what a real number is. Okay? All right.
When we say Cartesian plane, is it always spelled technically?
Yes, because it's always named after a person. Okay? All right. So here's an example of what that looks like. If you look at the blue dot there, it has a value going up and down, and it has a value going across, right? So if you go straight down from the dot, you hit the x-axis at what number in this case? 11. If you go straight across, you hit the y-axis at what? 15. So those are its two values. Okay? And we'll talk about them much more in a minute. Yes?
When you write out the values,
Yeah, we'll get there.
No, but do you put the y value or the x value first?
We'll get there. Hold on. I'm not going to tell you yet. Just deal with it for a minute. You're going to find out.
You've told us.
Okay. Now, extremely important. The point where the two axes cross is called the origin. And you will hear that phrase a lot, that word a lot, the origin. Now, if it's the origin is another way of saying where it begins, where it starts, right? Okay? And so everything when you're graphing begins at the origin. Okay? Now that doesn't mean every line you graph or every point you cross is going to be on the origin. It's just that's where you start your counting. Okay? So the point where the two axes cross is called the origin. Okay? At the origin, both axes have a value of 0. Now I want to talk about this one because this is a hugely important idea. Okay? Remember that on a number line, the number just tells you how far you're moving along the number line. Right? If you have a positive 5 on the x-axis, that means go to the right 5. Yeah? But if your number is 0, that means move to the right or left how much? None. If your y is value, if your other value is 0, that means go up or down how much? None. So be careful. Anytime you have a value of 0, that means move none in that particular direction. Okay? So every time at the origin, they both equal 0. Okay? All right. So we're going to go through a few questions here, just going through together. What is the defining feature of the Cartesian plane? Is it an infinite grid with no numbers or directions? No. One number line that curves to make a circle? No. Two number lines that are parallel to each other? No. Two number lines placed at right angles to each other? Yes. Good job. Okay.
Can you give us a picture?
Yep. What do we call two number lines which form a Cartesian plane? Axes. Excellent. Okay. What is the origin of the Cartesian plane? France, because that's where it was born, right?
The point where the x-axis and the y-axis
Crossover. There you go. Number two, where they cross, the point where the x and the y-axis cross over each other, right? Where they intersect. France. Okay.
What?
This is France. France. This is where it was born. This your person.
One of the planes from which it was drawn. It's
So, okay.
I
Was there another part of that question?
Yeah, you have to click all the correct answers.
I remember this from last year. Did we
Go back up. Wait, go back up. Go back up.
We've already done it. Yeah, and we did it last year.
Top left.
Nah, that's not the origin though. That's the only answer. Yeah. But they just describe it with a picture on there for some reason. Okay. The diagram below shows a Cartesian plane. The arrows in bold are its axes. Which one is the x-axis? The horizontal. Ever change? No. Okay. The diagram below, which one is the x-axis? Yeah, they were messing with you there. They asked for the same question twice, didn't they? All right.
You got the last one wrong.
Oh, did I? It said why?
Yeah.
Oh, I just read it wrong. Okay, sorry about that. Great. It's on the recording too. Yay. Oh, well. You know the difference. Y-axis is which one?
The
Vertical. X-axis is horizontal. Okay. Now, so we've talked a little bit about the Cartesian plane. We know the pieces of it. Now let's talk about how the numbers relate to each other when you're using it. Okay? All right. So the first thing is that when you are talking about using the Cartesian plane, what we're doing is we're describing what are known as points. You don't have to write that down yet because we'll talk about it because there's more information you need about it. Okay? So if someone says a point on the Cartesian plane, that just means a point on somewhere on the Cartesian plane. It could be anywhere, right? Okay. So for example, here's a point on the Cartesian plane, and we can describe it by looking at the values on their x and y axis. So first of all, if that's the point, if you go down, what number on the x-axis are you hitting? 7. What number does it correspond to on the y-axis? 3. Okay? And we'll learn how to deal with those and where to put them in just a moment. Okay? So you can describe it, right? The horizontal line lines up with the 7. That's the one we just did. The vertical line lines up with the 3. Okay. So we can write these Cartesian coordinates. Now, we have a short video. So here you go. So in the video, he referred to a point on the Cartesian plane as an ordered pair. All right? That idea of an ordered pair is probably the singular most important idea that you can have. All right? So an ordered pair is called that because the numbers will always be in a particular order. The order is not negotiable, right? So you make sure that you remember they're called coordinates or ordered pairs.
Doesn't it change
Okay.
what question is?
Well, you can have different letters, but the values and the movement are always the same. Okay?
Like name.
Yeah, you can between those two, not really, but yes, you can use different letters on the number lines, but they're always the same. Okay? Now,
Wait.
coordinates or ordered pairs is what it's saying. Okay. You can write it down. So, one number is shown simply by going along the x-axis, and the other is shown by its distance along the y-axis. And if you switch them up, you'll get a different point. So if you look at this one, on the x-axis, what's the value of the red dot? 7. On the y-axis, what's the value? 3. But look at if you switched them, if you put them in a different order. On the x-axis is now the value is 3. On the y-axis, the value is 7. So you must get them in order or you're not going to get the correct point. If you reverse them, you make a totally different point. Look how far off those are. Way different locations, yeah? So be careful. You have to make sure they're ordered pairs. They're in the order. So let's talk about the way to name them. Remember, each of them is simply a point on the number line, right? So keep that in mind. So here are what a Cartesian coordinate looks like. A Cartesian coordinate is always in the form x, comma, y. So your x value is always where?
Before the y.
Before the y. Okay? Which makes sense because that's alphabetical order as well, isn't it? So x, comma, y. What else is peculiar about the way they've written this? You have x, comma, y to separate the two numbers, but what else do they have there?
Brackets.
Brackets, you bet. And that is specifically reserved for coordinates on the Cartesian plane. You'll never see anything else written in that format. You can have a list of x's and y's. You can have this means x times y, but you will never have anything other than x, comma, y in brackets for anything other than a point on the Cartesian plane. Okay? That's how you know that it's a point on the Cartesian plane. Make sense? So, if you saw just x, comma, y, is that a point on the Cartesian plane? Nope, because it's not enclosed in a what? In a bracket. So the brackets tell us that this is a Cartesian coordinate or an ordered pair. I've just underlined it, so that means I want it written, please.
What would happen if it wasn't in brackets?
Then it's just a list of numbers. Right. So if you had 3, comma, 4, that's just a list of two numbers. Right? Now, put 3, comma, 4 in brackets, then it's an ordered pair. Okay? So the notation is critical. Good question. Okay? So the brackets tell us that it's a Cartesian coordinate or an ordered pair. Both mean the same thing. Otherwise, it would just be a list of numbers. Okay? So the brackets are important. Not only important, they're critical, because if you don't have the brackets, you don't have an ordered pair. So keep that in mind, because when we take our assessment and you don't put it in brackets, I'm going to say what? Wrong. Listed numbers doesn't mean a thing. Yes?
This is kind of a dumb question, but it does the x coordinate always go first?
Yes, this is why it's called an ordered pair, because it's always x comma y. They have to be in that order. Yes, ma'am.
You don't have to put on what side you were doing with this. You don't have to put 3x, 3.
No, it's not 3x. In this case, the 3 is the x value, and the 4 is the y value. It's a good question. Never thought about that really like that, right? Remember, those are just, x and y are just letters standing in for some number, just kind of like a form that you're going to fill out. Okay, good deal. All right. So, don't forget the brackets or it's wrong, in other words. So you can label points that we were looking at before. So look at this one. The x value for the purple one is 3. The y value is 7. So that gives you the ordered pair 3, 7 enclosed in a bracket. The other one, x value is 7. Y value is 3. So that gives you the ordered pair 7, 3 in brackets. And make sure you separate them with a comma. Okay? All right. The comma is important because otherwise you'd have 73 in a bracket and that doesn't mean anything to us anyway. Okay? Excellent. Okay. We always write the numbers on the x-axis first and the y-axis second. Always. And that way you'll know which one to put where, right? If you could just write them independently, then you would never know where they are, and they'd always land up in different points, right? We need to be all on the same page about which way they go. And again, it just happens to be alphabetical too. Right? So x-axis first, y-axis second.
Does that mean zeta's always third?
So if you had a third point. Okay? So, all right. Let's just look at a couple very quickly. The point on the graph below is at blank on the x-axis and blank on the y-axis. So, what is it on the x-axis? 8. What is it on the y-axis? 10. Okay? All right. And I'm not doing the rest of your homework. You can do that yourself. Let's talk about plotting points. So we know that we can read the x and y value from the graph. Right? Just look at where the dot is, find the x value, go across and find the y value. Yeah? So what we're going to do now is we're going to learn how to go the other way around. We're going to be given the ordered pair, and we need to plot it on the graph. So we need to talk about how to plot an ordered pair using its coordinates. Coordinates is simply another word for ordered pair. Okay? Good. All right. So, how can we find the point 3, 4? So we're going to talk about that. So remember, it's an x value and a y value. So first of all, the number 3 always tells you how far you're going to move along the what axis? The x-axis. The x is always the first one, right? The second number, the 4, tells you how far you're going to move along the which axis? The y-axis. Okay? So what I want you to write down from this is the first number, don't worry about putting the 3 in there. The first number tells how far you move on the x-axis. Okay? And the second number, again, don't worry about the number they give you. This is just in general. Tells you how far along the y-axis your point is. Okay? The first one is always x-axis. The second one's always which? The y-axis. Good. About there. Yes, no, maybe?
Pardon?
We're about there? Ready?
I'm doing the second one.
Okay. Okay. We ready?
Oh, no.
All right. So the point 3, 4 lies at 3 on the x-axis. Now notice, all they did was put a dotted line at 3. They didn't put the point at 3, because remember the point has an x value and a what? So it's going to be out. It's not going to land on one of the number lines. Usually they don't. There's one case where they do, and we'll talk about it. But if they have two values that are non-zero, then the y value is going to land at 4 on the y-axis. And so all we need to do is find out where that intersects. The easiest way to do this is simply to start at the origin, count your x value, which is 3, and from that point, move up your y value, which is 4. And you'll notice that the dot is at the intersection of x equals 3 and y equals 4. Okay? Yes?
Would that mean if you written out bracket 3, comma 4 bracket?
Yes, exactly. Okay? So, plot 610 on the Cartesian plane. So the first thing is we need to plot our x value. What's my x value in this case? 6. What's my y value? 10. So, starting at the origin, I'm going to go to the right 6 places, right? But I'm not going to put a dot there. Sorry. I'm not going to put a dot there because I'm not done yet. Okay? I also need to go up 10 places. And that's where my dot's going to be. Okay? So, you can think of it like this. The x value tells you either move right or left. Now, these are all positive values, but you could be moving left if the values were what? Negative values. Good. Then your y value tells you how far to move either up or what? Or down. Okay? Now, notice there's no word across there, so don't use it. It makes me crazy. Yes?
Could the question also be like, if you like started on the number? Like, could you like start on like...
Well, remember when you're just plotting an ordered pair, it always begins at the origin.
But if they were like...
No, they won't ask you that.
Okay.
Not yet.
But is it possible?
Oh, yeah. As you move forward, anything's possible, right? Okay?
Even the impossible.
There you go. Okay, we're not watching any more videos. I'm sorry. Okay. So, a Cartesian plane links two numbers together, and these often represent something. So you'll see, remember earlier I talked about you could have, instead of x and y, you could have t for time or c for cost. You can use other letters. And the reason you do that is because you're using the Cartesian plane to represent specific items. Okay? So for example, we might have a person who is 14 years old and 160 centimeters tall. We could use the Cartesian plane to link their age and their height. So you would have one axis labeled age and the other one labeled what? Height. And it technically doesn't matter which one, but here's a clue. If any of your values involve time, years, minutes, days, whatever, traditionally that's put on the x line. Okay? And so here we have age, which is a time, right? And we have height, which is an attribute. So the time is usually put on the x-axis. It's a convention that's almost universal. Okay? Now, that doesn't mean it has to be that way. If height was more important to you in what you were looking at, then you'd put height on the bottom. Doesn't matter, but traditionally.
So the x-axis is more important.
It's the one that's describing what's happening as you move along, right? So it tells you what's happening over time in this case, right? Because what's going to happen over time for most of us until a certain point, as you get older, what's going to happen to your height? It's going to get taller until a certain point. Then you're going to start what? Yeah. Okay. So you can call them S and Z. Gertrude and Penelope. Number of cats and number of glasses. Age and height. It makes no difference what the axes are called. You just remember that the first number is always which one? Horizontal. The second number is always which one? Vertical. So if you reverse the values, you better make sure that the numbers you're using are in the right spot, right? If you do age and then height, then the first number needs to be what? The person's age. The second one has to be the height. If I do age is the one going up and down, and the other one is height, then the first number has to be height. The second one would have to be age, right? So however you label your axes, you need to make sure your ordered pairs match that particular order. Okay? All right. So, as a convention, we always label the axes. part of what you're going to have to do is you're going to have to draw a Cartesian plane. And if you don't label the axes, it's completely wrong. Now, many times, the only label you have is just going to be X and Y. But if there's specific things, it needs to be labeled with those specific things. Okay? All right, so labeling the axes is very important. And then you can just plot the point. Remember, in this one, he was 14 years old and 160 centimeters tall. Now, something else I want to show you here that we may mention later, I'm not sure, is that the scale. If you look at the scale for age, what's happening? 1, 2, 3, 4, 5, 6, 7. So they're counting in what? Ones. But look up here. 10, 20, 30, 40, 50. What are they doing? Counting in tens. And the axes don't, the units on each axis do not have to match. You can count this one in ones or fives or hundreds or whatever. It doesn't matter. It needs to fit your data. If you're using really big numbers, then you'll use big numbers on your axes. But what is important is, notice that this is counting in tens all the way up and down. You can't start in fives and then jump to tens. You have to use the same numbers all the way up and down. Same here. You can't start counting in ones and then suddenly start counting in twos, right? If you start in ones, then you have to go all the way across that axis in ones, okay? But you don't have to write every one. For example, if you can be counting in ones, you might see some graphs where you have a 1 here, then a 5 there, and a 10 there, and then nothing written in between. But you can see that there are still 5 lines to get to 5, right? So they're still counting in ones, but they only labeled some of the points. Okay? So be prepared to see different versions of labeling. Okay? So, there you go. Boom, boom. There's that graph. And make sure you label your age. All right, so here's another thing about age. Age has a certain number of units, doesn't it? The units are years. Height was measured in this case in what? Centimeters. So you need a label, and if it has units, you must have units as well. Okay? Let's see. Last thing. Just saying we're going to practice. Okay? So what I'm going to do is I'm going to give you this. You can. We're almost out of time, so do. Yeah. Voice is changing. So do make sure you work on some of these as homework. Okay? Even if you don't complete it, I want to see some of them done, and so you can skip down a bit if you need to, but get some of them done. I know that you have other things going on, but try to get them done, some of them, a few of them, from each section before we see each other again. Okay? Hold on just a minute, let me stop the recording.